wabarakatuh. Hello guys, in this video, we will explain about the experiment about circular motion. It's myself, Rahmadinni Lasonia Putri, and my friend.
My name is Sylvia Muharani.
And please watching our video.
Purpose of the experiment is 1. Determine the relationship between speed and radius, and 2. Determining the relationship between centripetal acceleration and the radius of rotation.
In uniform circular motion, an object travels around a circle at a constant speed.
The circular motion is the
The
motion
velocity
of
of the object is the rate of change of position with respect to time.
a fixed
This
point.
velocity
For
can
an
be
object
estimated
to
by
move on
examining the
circle,
change in
it is
position
the
over a
force
short
that
time interval.
always deflects
The instantaneous
towards
velocity
the
is then the
center
limit of
of
this
the
estimate
singular
as the length
path.
of the short time
The force
interval
is
goes to
called
zero.
centripetal force. Regular circular motion can be said to be regular
Note that
accelerated
the direction
motion.
of the velocity
The
vector is
nature of
always
the circular
tangent to the
motion
circle.
is determined by angular acceleration of a constant, then omega
The
changes with
acceleration
the
of the
time,
object is the
a
rate of
a
change of
function of
velocity
time,
with
and the
respect to
motion
time.
is called
The
regular
acceleration of the
accelerated
object can be
singular motion.
estimated by looking at the
Of
change in
a
velocity over
equals
a short
0,
interval of
then
time.
omega is
Instantaneous acceleration
constant,
is then
then
the limit
the
of this
motion
estimate
is
as the
called
length of the
regular
short time interval
circular
goes to
motion.
zero.
In the regular circular motion, the time taken in the one revolution is always constant and
Note that the
called
direction of the
period.
acceleration
In
vector is
regular
always towards the
circular
center of
motion,
the
the
circle.
angular velocity of the object is fixed. The value of direction are
The
fixed,
magnitude of
so
the
both the
acceleration can be
indices
determined
and
by
the
noting
average
that
speed
over
will
short
be
time
the
interval,
same
the change in
as
the
for
position
the
vector and the
linear
change in the
velocity.
velocity vector
The value
form
is
similar
fixed.
isosceles
The
triangles.
direction is all changed.
This
The
information
angular
then leads
velocity
to a
is
simple
often
expression
called
for
the
the
angular
instantaneous
frequency
acceleration and the limit as the
because
length of the
it
time
can be
interval goes to zero.
obtained from the frequency, namely angular velocity equals 2pv or 2pt in per radian and second.
One, prepare all tools and materials to be used. The tools and materials used for this circular motion experiment are 1. Ballpoint pen rod. 2. Rope. 3. Upper and lower weights. 4. Ruler. 5. Clamp. 6. Stopwatch. 2. Insert the string into the hollow, cylindrical rod pen rod. 3. Tie weight at the end of. The bottom rope and weight be object at the end of the top string of the pen cylindrical rod. Load A serves as a weight. 4. Attach a clamp to the bottom of the hollow ballpoint pen so that the length of the rope does not change. 5. Measure the length of the string at the top of the ballpoint pen, the radius of the object's trajectory using a ruler. 6. Rotate object B 10 times. Try to rotate horizontally and stably. Calculate the time using a stopwatch.
Once we do the experiment, we will write down the data in the table. As you can see, this is the various in radius at 10, 15, and 20 with the data 3 times data. And we can write down the data in the omega velocity and the acceleration. And as the radius of the trajectory increase, both the angular velocity and centrifugal acceleration then decrease. Similarly, in certain cases, the addition of full lap time also has effect on decreasing angular velocity. The variability in the data indicates the existence of complex relationship between the radius of trajectory, time, angular velocity, and centrifugal acceleration. Factors such as free air friction or measurements uncertainty might have influenced the result. For Rahmadinni for follow-up experiment to detail this consular motion phenomenon. And once we have to ready to the data and to organize the data, we can answer the final test. The first one is, does the leg of the rope join the object have any effect of the experiment? Explain. Well, the leg of the rope plays a circular role in experiment of regular circular motion. The variation in rope leg affects the radius of rotation and therefore centrifugal acceleration. A change in the leg of the rope will result in a change in the radius of rotation and directly in centrifugal acceleration. the graph of the relationship between angular velocity, velocity with radius, and relation between centrifugal acceleration. As you can see, there is a graph about the radius along with the angular velocity with radius, and the acceleration. As the trajectory increases, there's downward turn in both angular velocity and centripetal velocity. Likewise, in the same situation, the addition of full lap time also has impact in decreasing angular velocity.
3. How is the relationship between speed or v and radius or r? The answer is the relationship of velocity or v to radius r is described through the angular velocity formula or omega, where increasing radius increases linear velocity if angular velocity is fixed. 4. What is the relationship between centripetal acceleration and radius of rotation? The answer is the relationship is A equals LV squared, shows that centripetal acceleration is inversely proportional to the radius of rotation. An increase in radius results in a decrease in centripetal acceleration and vice versa. 5. Describe the factors affecting the magnitude of centripetal acceleration. The answer is several factors affect centripetal acceleration, including linear velocity, radius of rotation, mass of the object, center force, and length of the rope. Greater linear velocity, smaller radius, greater mass, greater center force, and changing rope length can affect the magnitude of centripetal acceleration. The conclusion is 1. The relationship between velocity and radius in the context of regular circular motion can be described by the formula is V equals omega multiplied r. Research shows that the linear velocity or v and radius or r have an inverse relationship, where an increase in radius tends to lead to a decrease in linear velocity and vice versa. 2. The relationship between centripetal acceleration and the radius of rotation can be described by the formula A equals RV squared. The results show that the centripetal acceleration A and rotational radius or R have an inverse relationship, where an increase in radius leads to a decrease in centripetal acceleration and vice versa.
Okay, maybe that's all our video. I'm sorry if any mistake, and I hope you enjoy our video. Thanks for watching, and don't forget to like and subscribe. Bye bye.